Wait, my PowerPoint is not responding. Give me a few minutes. Okay, come. So this subchapter, later on, you'll be introduced with a psychometric chart. Okay, that one is you need to understand the chart in order to extract the info from it. Okay, before we move to that, I want to do one last exercise from the previous lecture. Okay, similar to previous lecture. Now, before that, these terms, you should be familiar with this term. Okay, we had came across few times. So when it involved phase change operation, it involved this kind of heat. Okay, the latent heat, heat of fusion when involve the melting from solid to liquid, heat of vaporization from liquid to vapor. Okay, so this one you should be familiar with the term. This is the latent heat, the graph enthalpy versus temperature. Okay. Now this one we had came across from the example table B1, where from table B1 you can extract the info of enthalpy, melting enthalpy, vaporization, heat of vaporization. Okay. So you should know where to extract the data for certain compounds. The heat of melting, heat of vaporization. Okay, and this table also you can find out their melting temperature and boiling temperature. Okay. Now this is HF is heat of formation, HC is heat of combustion. Okay, this one in following chapters. Okay, this one you can try on your own. Quite simple. I want to proceed with this. Okay, example 10, where it involves an equimolar liquid mixture of benzene and toluene. Okay, from the term equimolar, what do you understand? 50-50, same amount. Okay, so that's why from the PFD over here, we can see 0.5 mole of benzene and 0.5 mole of toluene. Okay, this example, eventually it has its process flow diagram. If the question doesn't provide, then you should know how to draw it. Okay. Now, this process enter at 10 degrees C, fed continuously to a vessel in which the mixture is heated to 50 degrees C. Okay, so from 10 degrees C to 50 degrees C. Now, the liquid product is 40% of B. Liquid product, and the vapor product is 68.4 mole of B. So meaning that you have two streams of product, one liquid, one vapor. This one is vapor, this one is liquid stream. Okay, so the question asks how much heat must be transferred to the mixture per gram mole of it. Heat here involves the Q. Okay, so the Q over here. How much of Q that it needs to heat up from 10 degrees C to 50 degrees C. Okay. Now, along the way in the calculation later on, you will see the solution ignored the pressure. Okay, this is because this one. Okay, this example I extract from the textbook. Okay, this comes from the textbook. It is not me who create this statement. Okay, this is from the textbook. Okay, so since we do not know the feed stream pressure, okay, the inlet pressure, it doesn't provide. Okay, so we assume that delta H for the change from 1 atm to P feed is negligible. Okay, how you can assume negligible since the process is not running at an unusually low temperature or high pressure. Meaning that you see the pressure involved 10 to 50 degrees C. Not unusual low means the process is not at, let's say, negative 20 until 500 degrees C. Okay, so if it is in the range of normal temperature, we can assume the pressure can be ignored. Okay, so meaning that later on, you won't be using to find delta H, you won't be using this equation since we ignore the change of pressure. Okay, so later on, no, this equation will be used. It involves only the change of temperature. Okay, you need to understand the process first. And then what is the required value, then how to calculate the value. Okay, previously, from previous example, you are given the mole of the products. Okay, mole of products. So from there, we can calculate the material balance. Now, in this example, the mole of vapor and liquid is not provided. So in order for you to proceed for energy balance, you need to complete the material balance first. Okay? Because Q later on, your Q will be equals to delta H dot. So this H dot is equivalent to N dot. Multiply by this one. But this N dot for outlet is not given. So we need to find it first. You only given, you have inlet flow rate. Not flow rate yet. Mole. Inlet, you have 1 mole. Okay, in order to find the outlet, so NV plus NL. We know that in material balance, in equals to out. Okay, in material balance, in equals to out. So N in equals to NV plus N liquid. Okay, up to that, can? Now we go step by step. We must complete the material balance first. If you still remember from previous chapter 2A, the steps. Before you calculate the energy balance, the reference state, the enthalpy table, the first step is complete the material balance. Okay, in previous example, we don't proceed with the material balance because all infos are provided. Okay, now we go step by step. It is in the solution, but I want you to understand the step by step how to do it. Okay. Now, first thing, the material balance. Okay, we know that NV plus NL equals to 1 mole. In equals to out equals to in. So from here, I copy back this diagram so that later we need to refer. Okay, follow me closely. Stop me whenever you are stuck. Now, NV plus NL equals to 1 mole. In equals to out. So from here, we do the material balance. Okay, this one is the first equation that we get. Then from here, 0.5 mole of B or T. Sorry, this one 0.5 mole of B. Okay, now equals, this one is the input, equals to the output for the B and vapor and liquid. Okay, so this is the second equation. This one for butane. Okay, now we have two equations. Sorry, 1, 2. From 1, okay, from 1, we can rearrange so that it becomes the NV equals to 1 minus NL. Anything? Sorry, benzene. Sorry. Not butane, sorry. Benzene and toluene, correct. Thank you for that. Okay, now from here, we get third equation. Now substitute 3 into 2. Subs 3 into 2. Okay, so once you sub 3 into 2, from here you have only one unknown, which is the NL. Proceed, then you will get your NL value. So you should be getting 0.648 more for NL. Then from there, using equation 3 just now, you can calculate the NV. What you get, Sharmina? Yes, 0.352. Okay, please double confirm whether NV plus NL equals to 1. Okay, if you get not equal to 1, then something wrong with your equation calculation. Okay. So we have completed the unknown for metric balance. And V is known now, and L is known. Okay, then complete the process flow diagram, the PFD. Okay, this is the complete process flow diagram. The unknown that we calculated earlier, this is NV, this is NL. Okay. Now from here, then only we can proceed with the energy balance. Okay. Now to proceed to with energy balance, again we repeat the same step. Find the reference state. Okay. Find your reference state. In this example, it used the benzene and toluene at the inlet as the reference. Okay, you can choose your own, but to make it easier, it's better to use the inlet. Okay, so construct the enthalpy table for inlet and outlet. Remember to list down all substance for each phase. Okay, benzene for liquid, benzene for vapor. Okay. From the enthalpy table, you can see the inlet involve only the benzene and toluene in liquid, because this is the only feed that you have. Then H equals to 0 because this is used as reference. Okay, that's why H is equals to 0. B vapor, T toluene. Why this one is dash? Not appearing in the feed. Okay, because we don't have vapor phase in the feed, only liquid. Now for the N out, how do you calculate for the N out? Wait, I copy back. Soon. Okay, how do you calculate the BL outlet for liquid benzene? From the figure over here, this is vapor, this is liquid. Okay, so for liquid benzene, this multiplied with your NL. Okay, make sure you get this. Zero 0.648 is the NL that you get just now, multiplied by the mole of B in liquid stream. Okay, same practice for liquid toluene, where 0.6 multiply with your NL. Okay, NL 0.648. NV 0.352. Okay, so the same thing for the rest. You should be getting this figure for your N out for both stream, liquid and vapor. Okay, now we have 4 enthalpy that should be calculated. This one, I leave it to you. Work in pairs. Choose one enthalpy. Which one that you want to work with? Only work with that one enthalpy. Then later we share the answer. Work with pairs, so that you can discuss. It is a long calculation. So that's why I ask you to choose only one enthalpy. Okay, try to work out. Remember, it involves phase change. Change of temperature. Pressure is ignored. Okay. Same approach as previous example. To find the H, you need to use the CPDT, integration of CPDT. Now choose your H. Which H that you want? Who's looking out for his man? Or you need to call? We take some time if we proceed. Or yeah. H3 is a long step. With people. Yes, those who are done, share your answer if you want. Yes, sir. So, Thank you. Now the rest say H1, H2, and H4. Okay, the answer is correct. So you must do the hypothetical pathway first in order for you to understand what are the infos that you require. Okay, H3 is from, this is the reference name to the product. H3 involves the product. Okay, so from liquid to vapor, 10 to 50. What you need to know is the boiling point of the benzene. Okay, here why it shift from 10 to 80 because this is the boiling point of the benzene. Okay, so TB is 80 point. So this one can be obtained from table B1. Okay. Now change temperature, phase remains, still remains. From here to change phase, liquid to vapor, and here it involves the heat of vaporization, CP, heat of vaporization. Then from here, change to 50 degrees C. From 80 to 50 degrees C, so you need to do the CPDT, okay, integration of CPDT. Change temperature from 50 to 80. Final answer is this. This is correct. Okay, so H3 is the summation of all of this. H3A, 3B, and 3C. Okay. Now, can I have another enthalpy? H1 from potato. H2 random. Sabak. H4 from random. Okay, thank you for that. This one is integration of CPG from 50 to 500 to 50 to 10. Because it involves temperature change only, not phase change. Phase remain from 10 to 50. So do the integration of 50 to 10. This one you can take from table B2. Okay, the values of the A, B, everything. Which form? If the form 1 or form 2. With the B2. Table B2, right? Okay. So all the values of A and B you can extract from the table, then plug in into the equation, so you get your final answer. Okay, this is correct. H2, same thing. Okay, I give you the final answer only because I need to proceed to psychometric chart. Can I? I give you the final answer. H2 and H3. Sorry, H2 and H4. Similar step. H1 and H2, same step. From 50 to 10. Okay, but it involves different substance, toluene and benzene. Okay, this one I give you the final answer. You must try to work it out how to get this final answer. Okay, so from here, what you need to do is sum up all together. So the Q equals to delta H dot, which involve the N inlet and outlet. Is subs in all the values for out this part. Okay, you do it one by one for benzene, toluene, both for vapor and liquid phase. Okay, add up all together. Then your final answer, you should be getting 17.6481. Okay, if difference by a few decimal points, doesn't matter, as long as the mean is 17. Okay, any question for this example before I proceed? You must follow the step. Make sure first step, material balance is complete in order for you to proceed for energy balance. Okay, and the energy balance, find your reference state. Then from there, proceed with the enthalpy. Either you need to do the hypothetical way or you can straight away extract the info from the table. Okay. Now, okay. Some of your friends still calculating. Just give few minutes. Yes. Okay, this one just to introduce you first. Next class we'll go into detail because later on I need you to watch one video. Before you watch it, I want you to know the terms first. Okay, go back later. Please watch the video. I will share with you the link. Now, this is psychometric chart. What is about psychometric chart? Any idea? Humidity. It tells you about the humidity. Humidity of what? Air. Humidity of the air. Okay. So it involves H2O and air only in this chart. You see there are a lot of lines. Okay. So many sort of infos you can extract from this psychometric chart. It's just that how to know, how to read it, okay, and what infos to extract. Down here is the dry bulb temperature. Okay, you see the terms. Dry bulb temperature is that temperature without moisture. Dry bulb. So here is x-axis is dry bulb, y-axis is moisture content. Kg moisture content, okay, the kg of moisture content in kg dry air. So means that in 1 kg of dry air, how much of moisture content that you have? This one is normal, X and Y. But we have a lot more. If you notice, this line, it is the percentage of the humidity. Okay, percentage of humidity. And then this one is the enthalpy deviations. This diagonal line is the enthalpy. This is enthalpy. But this line is enthalpy deviation. How much it deviates from your enthalpy reading over here. Okay. And then this one is wet bulb saturation temperature. Wet bulb. So means you have moisture in it. This one is dry bulb, wet bulb. Okay. This one is enthalpy. Relative humidity. Okay, enthalpy deviation. This one have one more. See this one. It's diagonal. This is another info on the psychometric chart. Okay, so later on, let's say you are given a condition where at, for example, 40 degrees C dry bulb with 10% relative humidity. So let's say here 40 dry bulb, 10% relative humidity over here. So here is the point. So from here, you can get what is your moisture in the kg dry air. Okay, and then here also you can get what is the enthalpy and what is the deviation of the enthalpy. Okay, and then what is your wet bulb. Okay, a lot of infos over there. So from that info also, you can calculate what is the volume of the moisture. Okay, so this one I introduce you the term first. This is the chart. This one will be given in your final exam and test. So you should know how to use it. So the term of the charts, these are the few terms of the chart. We have absolute humidity. Absolute humidity just now is the y-axis. Dry bulb temperature, the x-axis just now. Wet bulb, dew point. Okay, just now you have also the axis for dew point. Then relative humidity, humid volume. Okay, from that one psychometric chart. These are the values that you can extract out. Specific enthalpy, and also the enthalpy deviation. Okay. Now, actually, I have one video. This one, later on, I'll share the link. You will be more clear on how to read the psychometric chart. Okay. Please watch this video in order for us to proceed to this example next class. Okay, so usually you will be given two conditions, dry bulk or dry bulk and wet bulk. Okay, in this example, dry bulk and wet bulk. So dry bulk, let's say 30 degrees C over here. Wet bulk, 25 degrees C. Okay, this line, wet bulk. Let me make it bigger. Okay, wet bulk, 25. So this is the point. So from here, you can get all these values. Okay, so I'll share with you the link. Please watch it so that we can proceed for the example in next class. Okay, Ken? Okay, that's all for today's class. If you have any question, can ask me. So this one, for those who haven't scanned,